Hey, hello everyone. Thanks for hanging out to nearly the last talk. I know Duncan is officially always the last GrrCon talk, but thank you for hanging out to the nearly last one. Everyone having a good GrrCon? It's a good event? Yeah? Woo! Chris and Jamie and the whole team, they run a fantastic event, so I hope you're enjoying it. Thank you guys for the volunteers. I really appreciate it. This is excellent. So this talk is Bounty Hunters. My name is Wolfgang Gorelick, and occasionally my clicker works. Like that. Good. I'm with CBI. I run a strategic security programs practice within CBI. That's like data and identity and governance and pretty much nothing we're going to talk about in this talk, but that's who I am. I'm also on YouTube, and I talk with my hands way too much, which annoys the hell out of the Redditors, by the way. Anyone on Reddit? Yeah? Everyone on Reddit who sees my videos like, you gotta put your hands on the wheel. I'm gonna call your insurance. I'm like, you should. Call my insurance. That would be great. By the way, it's progressive if anyone from Reddit is watching. I'm not giving you my policy number. But yeah, so I'm also on YouTube and I do a bunch of things. When I was a kid, I used to wake up at 4 o'clock in the morning. I woke up at 4 o'clock in the morning for the spaghetti westerns. So if you're about my age, you may remember it was 4 o'clock, channel 20. We only had 3, 4 channels. It was terrible. It was a little bit gray, a little bit grainy, but Clint Eastwood would come on, and it was fantastic. And about 6 o'clock, I was in my glory, and I'm like, I want to be that guy. I want to be the gunslinger. I want to be the bounty hunter. I want to be the guy riding into town and shooting up the bad guy and putting him over my saddle and dragging him home for coin, currency, and swag. And I did not understand why it was called spaghetti western. So about 6:45, I was waking up my parents and go, can I get spaghetti? And they're like, you are nuts, kid. But that mentality and that picture stuck with me forever. So when bug bounties became a thing, I got really, really excited about it. I love the concept. So for those of you guys who are new to this concept, it works something like this. There's no saddle, there's no gunslinger, there's no spaghetti. Why is there never any spaghetti? But what happens is all the great things about hacking that we know and love, we get compensated for, and there's a legal and ethical way to do it. Companies build software. As we all know, software has bugs, lots and lots of bugs. Companies put out a bug bounty program. It's a legal framework. People sign up for that bug bounty program or sign up through a number of organizations like HackOne and BugCrowd to come in and participate. You hack stuff, you do stuff, you find vulnerabilities, and the companies pay you. It's fantastic. And you do it all for coin, swag, and glory. This talk is about some of the things that bug bounty hunters find. It's about some of the common ways they break in, a series of stories that highlights that thing. It will give a quick framework of how to address these vulnerabilities and some things that you can do at home to play along. Some of the things other about bug bounties, some common misconceptions. One of the things is like, oh, we can't do a bounty because the bounty hunters can hack anything. And companies can oftentimes get very concerned about that. So if you're a company looking to do a bug bounty program, I highly encourage you to check it out. There are legal restrictions around it. Hackers, you can usually trust them. Usually. Kind of. People are chuckling in the background, especially the guy with the piñata. But you can usually. I mean, within reason. Also, too, the other concept that a lot of organizations get concerned about is when you're doing these bug bounties, can I actually trust the company? Will they pay me fairly? Will they not sue me? There too, for the most part, as these bug bounty programs have matured, we can trust them, they can trust us, we can all come together, which is good, it's not a free-for-all, it's not anything goes. So let's look at some examples of what happens with bounty hunters. One of the first ones I want to talk about is Aquatone and Uber. First off, anyone run Aquatone? Anyone play with it? Couple folks. Most people are like, oh, you should Google this. You should check it out. It's awesome. It won someone $4,500. I'll get to that in a minute. Really cool tool. So Uber puts together a bug bounty, and they run this bounty program for quite some time. Very, very successful. Lots of low-hanging fruit was found with this program. Lots of folks came in, and they broke the app, and they broke the back-end website, and they broke all sorts of things. This screenshot comes from one of the bounties where they were looking for domains that could be hijacked. So what Aquatone does is it will run across domains, and it'll find domains that you can go ahead and take over, right? So you run this tool, Aquatone take over. Pretty simple, pretty straightforward. You run that tool, you run it against your target. Thank you for that. politicians, and okay, you run against your target, and it will come back with a bunch of lists of domains that you could potentially take over. Specifically with Uber, they were on CloudFront. So it runs across CloudFront. They find a bunch of domains that you can take over. You execute that domain takeover. You use AWS. You point it to that subdomain. Now, such and such .uber.com belongs to you, and you can profit. This particular researcher set up some things through Beef and tracked a whole bunch of who was going through it, came up with a really nice report, and profited $4,500, which I thought, awesome. Run a tool, win $5K. What's wrong with that? One of the things that's very interesting about bug bounty programs and about the whole script kiddie mentality in general is there are so many ways that we make mistakes, right? It's the whole if Shakespeare, or if you gave a million monkeys typewriters, they'd all type out Shakespeare. We've all heard that a million times. If you give a million monkeys a bunch of code, they'll produce a million vulnerabilities everywhere, and they'll publish it up on Amazon, where you can take over the domain, and it's okay because S3 is also open, and if you want additional data that's there, it's probably credit cards, you're good. Right? There's so many things out there, so much low-hanging fruit, and that's one of the things I think bug bounty programs are very good at. Open it up, everyone come in and hack, run your favorite tool, sharpen those skills, and find those things. You don't want to pay a pen tester for that, right? If you pay a pen tester to fully test out all your domains at pen tester rates, weeks upon weeks upon weeks, oh, that's expensive. So for a company, it's pretty good as well. You get some of the best of both worlds. So this is one against Uber. We have a very similar situation happened with Azure and Starbucks. So Starbucks is running a bug bounty program as well. One of the domains that was open was SBC Gateway US.starbucks.com. That was on Azure. So on Azure, they found that. They created, they opened up the Azure page. They took that, threw it in. That's now my domain. Fired it up, and now all the code that was going to that goes to the attacker. Now, of course, SBC Gateways US is probably something that people are not typing in a browser on purpose. But that can then be, from an attacker perspective, if you're not using it for a bounty, a way to get onto future attacks, right? Especially if they're whitelisting Starbucks.com and you want to do a phishing attack and now you own that subdomain. A lot of cool little things you can do for that. So it happens in AWS, it happens in Azure. This is one of the common attack vectors we're seeing with cloud that a lot of folks never really thought about when it was all on-prem, when you owned your own DNS and things were much more tidy. So some of the defenses against that, obviously domain and subdomain inventory, knowing what you have in DNS, which should be simple, right? We should know what we have in DNS. But with things like DevOps and things like rapid and deployment and everything else, and everyone can create their own DNS, it's very common that we end up with gateway, SBC gateway.us, or app tier 1, or, pry wolf's testing it's okay, I promise.microsoft.com, things like that, right? 1,000,001 of these test domains are being created all the time. So they're out there, and they're easy to catch. The other thing to do is not only have a good inventory, but routinely check, and then clean up those unused domains. If you have a software development lifecycle where you're letting the developers create their domains, at the end of that process, we want to have a thing that stops, cleats, and deletes those domains, right? So just some good software controls around the inventory. Another bounty that I thought was pretty interesting was from a while back. It was from Nest. Is Nest even still around? You guys got Nest? Is that still a thing? You laughing at me, you're like, it still is. Yeah. There's still Nest. It's still a thing. Okay, good. Yeah. That was what I thought. With ABC, done. Now everyone's making their own thing. But, hey, people still buy it. Who knows? I mean, if Elon Musk left Tesla, that people would be buying Teslas forever. So it makes sense. Well said, sir. All right, so what Tesla had was Nest, in the early days, had a certified reseller program. They're trying to build the reseller base. Anyone could sign up for and become a reseller. And so they built this website where the resellers could come in and upload their certification, right? I certify that I am a reseller. Here's my certificate. And that's awesome. That's great. So now they prove that they're a reseller. They do the reseller thing. Life is good. On that There was no validation on the upload, whatever. It's supposed to be PDF, but there's no check as to what it was. And not only that, when it uploaded, it went to a folder on an Apache site that also had browse and execute permissions set on it. So as you might imagine, you upload a PHP shell, bam, you're root on that register reseller site. This was one that was found during one of the Google blasted out bug bounties. And I thought that was pretty cool because, again, how many different websites do you have out there? And if you think about a certified reseller program, if you're a company, you're like, I'm going to start a reseller program. Are you going to have them come and pen test that? Probably not. You're not going to have money for it, right? We'll pen test our financial services app. That's what we'll pen test. But that reseller app then with that shell, along with a phishing campaign or along with, blast out email to all the resellers, come back in and then use that as a pivot, all sorts of cool things could happen. And of course, PHP shells are on the rise. This chart is a little out of date. I use this chart, I pulled this chart when, Equifax happened. So it shows the level of web shells bouncing up into the Equifax attacks. Something about 90% of all shells today are PHPs. So PHP web shells getting uploaded. And why that Equifax thing was kind of cool is, do you guys know how many different shells were uploaded in the Equifax attack? Anyone want to guess? One attacker, two attacker? You in the mass shootings. Right on. So with Equifax, because that vulnerability happened in struts and everyone jumped on it, like 1,000,001 monkeys, right? 1,000,001 attackers, the common, the curious, the criminal, to be sure, were scanning for that struts vulnerability. Within Equifax, when it got hit, it didn't only get hit once and breached. That's the story that everyone heard, right? It got breached and they put in a shell and everything was bad. It got hit over 40 separate times. When Mandiant came in, they found over 40 different shells uploaded because of that vulnerability. And they had command line monitoring, too, on that. So some of these like super attackers that went in and found the struts vulnerability ran cool things like, who am I? And went, I'm root on Equifax. And their IP address was never seen again. You know that someone was like, I'm going to tell everyone I did this and hope no one notices. Right? You know what I'm saying? So what if Equifax had done a bug bounty program, right? What if they had invited everyone and their brother to attack these sort of things? And that who am I kid had gotten $5,000 a pat in the back, right? And then used some of that money to come to GrrCon, of course. That would be much better, I would argue, than waiting for everyone and their brother to try it once a Metasploit hits and loading up PHP shells. So some defenses against this, arbitrary file includes, right, what do you want to do? Most people blacklist, don't allow PHP, don't allow exe if it's a Windows, yada, yada, yada. Many people also whitelist. If you're only looking for PDF, just look for the PDF extension. This is kind of like the old school way of doing it. A lot of the new frameworks and new languages will actually do file type detection, which is fantastic. It'll read the first few bytes of a file, just like an OS would, and say, yeah, nice try, shell.php.jpg. I know what you really are, right? It will actually look at and detect and prevent it. And of course, along with that, if you somehow bypass that, upload, then have some restrictions on your folder so that when files go into them, they're not executable right away. So read only where they need to be, or heck, if you can prevent it from read-write, prevent altogether. All right, next one I thought was kind of cool. This one has to do back with Google. Google is like the #1 consumer, I found, as I'm reading a lot of stories about bug bounties. And Google Calendar got beat on quite a bit. One of the things I thought about was neat about was the way the command actually ran. So most people use Google Calendar. Yeah, I use it all the time. Okay, with my Progressive insurance, great. Now I'm going to be in for trouble. You ever get those bugs where it emails you like the same calendar invite like 3-4 times? You're like, what the hell is this? I'll delete it. I'll mess up. Clearly they're having a glitch. So maybe I email you once, twice, again, and eventually they're like, what the hell, I'm going to just delete this. That common pattern, especially in the early days of Google Calendar where it glitched a lot, you would see that 3 or 4 times. It would just keep emailing. You're like, I don't know what I did wrong with this calendar. I'm going to delete it and recreate it. This particular bug was found that they could embed XSS through the API, through the application API interface into Google Calendar. So you open up with Google, you say, okay, certain applications go right to my calendar, like if this, then that. And on that interface, there's the ability to have actions on deleting calendar invites. So you use delete to insert some JavaScript. Classic cross-site scripting over JSON. So you insert your JavaScript into the calendar invite. Now the calendar invite will only trigger if it gets deleted. So now you got to convince the user to delete it. So again, you keep sending it to them again and again and again until they eventually delete it. Usually the researchers found it took about 5 times. I think that's kind of interesting. That tells us something about human nature. We will pay attention to Google's BS 5 times and then we'll click delete. Fun fact. But so you send it again and again and again, and eventually the person's like, this is ridiculous. I shall delete this invite. The minute they do that, that action executes that JavaScript that's been embedded in it by the API hook. That cross-site action runs, and now they get a little JavaScript pop-up message or whatever it is. They click it, of course, make it all go away, and when they do, that JavaScript is executing on their box. Kind of an interesting, kind of cool, kind of clever attack. Something I would have never thought to try. And that's another thing I like with bug bounty programs, is because you have a little more time to think these things through, a little more time to play, a little bit more time to try different scenarios. You can come up with weird things. Like, what happens if I embed, something on a calendar invite? What happens if I screw up with this particular executable or upload this file? With pen tests, and you talk to most pen testers, they'll give them a couple drinks first. I should add that. Always give pen testers drinks. Come bearing offerings. And say, hey, how frustrated do you get when you have a tight scope? Drink 0, they'll go, oh, that's no problem because we can always provide the best possible value within the time constraints. Drink 3 or 4, man, I could have got it, and I was right there, and I'm like, the report's due in an hour. I'm like, oh, just 5 more minutes, but I had to write the report, and I didn't know, Drink 6, yeah, they're taking you to another bar, and it gets really exciting. Drink 6. But my point is, pen tests are limited in time engagements, right? So therefore, the results are always limited in time. Whereas bug bounties, more people, more time, more flexibility, you can have a lot more time in your leisure to come up with some really cool, really slick attacks. And a lot of the attacks I see from bug bounties are much more exciting because of that. The embedded calendar trick is just one really good example. And I love that because I think that gets back to the true nature of hacking. When a lot of us get into it, we're doing it, before school, 5 minutes here, 10 minutes there, running out the door, jotting down on a piece of paper, oh, I'll try this when we get home. And having a more of a free-form, with no restrictions, with no restraints approach to it allows for a lot more creativity, I think, in some of our attacks. Really, really interesting dynamic. The other thing I want to point out is JavaScript, right? When I say JavaScript executes in the box, most people are like, yeah, okay, so what, right? We did MySec, right? MySec's a user group. A few people in here with MySec, yeah? All right, woohoo! MySec. So my favorite cross-site scripting talk of all time was at MySec. I was sitting in there. I was sitting there with a couple of my friends. One of them ran the data center that we were in. Not necessarily the most technical guy, but very astute, very smart. And another guy was an operations guy. He kind of knew how things worked together on an IT side, but not really a hacker. And the whole room, a bunch of hackers. And this was a MySec meeting where they were explaining cross-site scripting. And the speaker was Josh Little. And Josh Little's sitting there. He's got a flair for the dramatic. So he's like, here's the JavaScript. Here's what goes in. Here's my input. Bam, I've got you. And it pops up a little, message. Haha, I got you. And he goes, all right, now I'm going to put in this control. He puts in this other control, does it again. Little message pop up. Haha, I got you. Does this again and again. And by the time it's like 6, 7 times, every time it's haha, I got you. We're like, yeah, you got us. Yeah, we got us. And it was really getting exciting. We're all cheering and we're all jumping down, except for the CIO because he's very reserved. He's looking at us like with us. But we're all cheering and we're all getting into this. I'm like, yeah, we got us. Yeah. And there's this bypass and that bypass and this control. And he went through like 6, 7 different ways of cross-site scripting. Go to the OWASP Detroit or OWASP page. It lists them all out. You can follow that on your own. But he goes through all this all. And the very last one, we're like, and there's no dialog box. And we're like, the fun's over. He's like, yeah, I guess it didn't work. So let me log into my banking. Let me log into this. Let me log into that. What we neglected to realize until about 2 minutes into this description was that he had actually, instead of popping up a JavaScript, hey, I got you, he had ran the Metasploit keylogger. So he was doing JavaScript keylogging. He's like, anyone else want to log in? And by the time he like flips and showed, granted he didn't log into his real bank account, but by the time he flipped, everyone in the room got silent. And the little director guy, not so little director, but the director guy's looking at me, and the CIO's looking at me, the data center guy's looking at me, and he's mouths to me like, why did you guys invite this guy? I'm like, it's okay. Just log into everything when you get back to your desk. It's all fine. Just only if you see the box that says, hi, I got you. Do you really need to worry? But we think that, right? We think, oh, cross-site scripting, yada, yada. But with the tunneling that's in place now, with the key logging that's in place now, with a lot of the new Metasploit payload, cross-site scripting is incredibly, incredibly weaponized. So just keep that in the back of your mind. Some defenses for this. Obviously, escape all inputs. Your HTML, your JavaScript, your attributes. Website folks have gotten pretty good at this. UI folks have gotten pretty good at this. Awesome. Where we're seeing most of the bug bounties, also, too, where we have most of the fun we're doing pen tests, is on the APIs. Because there's a mentality with developers that if it's hard to build, it's probably hard to break. There's also a mentality with the hackers that if it's easy to break, it's probably easy to fix. Therein lies a tale of two completely different cities, and that's where most of the fun comes in whenever you're reporting any sort of result. But building APIs, most people don't browse APIs. Right? Most people don't use APIs. Most people are not typing in servicegateway.amazon.com or starbucks.com. Most people are using the front-end webs. And therefore, a lot of the times when a developer is creating an API, they're not necessarily putting in those same types of restrictions that they would have put in heretofore if someone was using a regular input. Because like, oh, an input is a text box, or an input is a file upload, like I covered earlier. A lot of people are not going, oh, an input is every single time I send JSON. Every single time I make a request and send you some data, that's some input, you better be escaping that. We forget that. We forget that. And when we forget that, new bounties open up, new bugs open up, the world changes. So one, escaping all inputs. And everything is an input these days. Number two, of course, is using platform-specific XSS protections. As I mentioned earlier, there's a whole bunch on OWASP. Depending on whatever platform you are, go to that documentation and pull it down. There's a lot of new frameworks and modules in place that will add it to it, which is awesome. You just got to remember to wire it up. And again, why I think the front end XSS is somewhat on the decline is because the front end nowadays, with a lot of the modern UIs, will put that in there for you, or IDEs rather. We'll put that code in there for you. So, cross-site scripting and messing around with Google. Another one I want to talk about is cryptocurrency. So, the blockchain, right? I've mentioned blockchain in abstract. I'll get called to speak. Blockchain is fantastic. I did a talk. You guys can catch it on Iron Geek's page if you want to, along with this one when it goes live. I did a talk with Zach Sarakin on cryptocurrency and classic cons. What's kind of interesting about cryptocurrency today is a lot of the security around cryptocurrency and the blockchain is all around the hardcore mathematics. It's all around what happens if there's a split, or what happens when we hit quantum computing and they can break crypto, and now we've got qubits that are, it's all about these sort of like very advanced, very sophisticated attacks that are now made possible by this very advanced, sophisticated technology. What I would argue you guys think about, be it blockchain or cloud or whatever the next crazy thing is next, right? AI, with everyone wants to talk about AI now, is whenever this is new technology, everyone's concerned about those new threats. But before they get to the new threats, what is every criminal and their brother going to try? What is every bounty hunter and their brother going to try? They're going to try the things that work. They're going to try the same old classic cons that have happened again and again and again. By that I mean, if you look at cryptocurrency, where they're all worried about all this sort of stuff, what people are doing is phishing scams and stealing your keys and pump and dump. Most of the money's going to those things, right? Especially like pump and dump and pyramid schemes. You're like, oh my goodness, this is like a 100-year-old, 200-year-old scam. Alive and well with cryptocurrency. I had one guy, great friend of mine, was like, hey, can you give me some advice? I'm like, sure, I want to do mining. That sounds great. He's like, so I'm told I have to buy a mining contract? I'm like, is it our land grab on like GPUs now? But there's like a whole like scam running around where they're selling mining contracts. A little piece of paper that says you are now eligible to mine Bitcoin. They're like, oh, that's awesome. I can mine Bitcoin. Ugh, classic cons. So one of the things that happened was Dash. Dash is a digital currency. Dash has a wallet. Dash wallet is called Copay. And Dash got on board and did a bug bounty, and everyone piled on top of Dash and broke it in 1,000,001 ways. One of the ways they broke it, which I thought was kind of interesting, was they found that when you install a wallet, it will write the private keys of that wallet to the log in clear text. For those of you not laughing, if you have the key, you are able to steal every single last penny or Bitcoin or Satoshi or whatever cool term you want to use from that wallet, because it's public-private key encryption. If you have that private key, you have the wallet. So the bug bounty was all around finding that flaw, right? There was in debug mode. That was problem number one. Debug mode would cause all the keys to get written to the log, and the log had then the clear text version of the key. One of the things that I thought was pretty interesting about this is it reminds me of Twitter. Everyone remember the whole like freak out about Twitter? Because all the usernames were, and not all the usernames, sorry, Twitter, apologize. A fraction of the usernames and passwords, which have not yet been disclosed, were written to the logs in clear text when people were logging in. Oops. And then, of course, they had to disclose that that had happened, and a whole bunch of people were giving notices, and we all had to change our passwords, and everyone in security went, oh, no, you guys are terrible. And we all piled on Twitter for a while. What? Yes. Yes. Wall of cache, wall of fail. All right. So that's one thing that's interesting is we've seen repeatedly big companies fall prey to this concept of if it's in our logs, it's fine. Nothing goes sensitive to our logs. Our logs are only for metadata and some other attributes. And then there's a mistake, like debug mode gets turned on or Twitter gets modified, and it writes all this stuff to the logs, and now it's in clear text, and now we got a breach. Similar thing has started happening with same concept, different implementation, with big data implementations, right? Oh, we've got elk. We'll just throw everything elk, all right? We've got a data lake. It's fine. The data lake is all pristine. I was talking to someone, and they're like, we're going to implement a data lake. I'm like, that's great. What are you doing for security? Oh, we don't need to secure it. Why not? Well, because it's only going to have, like, I think it's anonymized. You think it's anonymized? Yeah, I'm pretty sure. I mean, it's just usernames, right? That doesn't, and people's names and addresses, and maybe an ID. I'm like, oh, okay. Yeah, it's anonymous. And who can get at it? Well, everyone, because we're doing analytics. Oh, okay. Okay. What is your company so I don't buy from you? But that's just human nature, right? We think of the log as something that's not necessarily needs to be protected. We forget that anything can be written to the log. The other thing that's interesting to me about this is Dash immediately said, no, that's not our problem because we're a fork of Bitcoin wallet. Bitcoin's Copay was where the original bug happened. When Dash built their Copay app, they forked Bitcoin's Copay app and went, great, we'll start with this and we'll change the logo. It's Dash. I love open source. Don't get me wrong. Fork the heck out of everything. But perhaps when you do fork, check the code you're forking. Because once it's now forked, it's now your code. Even if you didn't write it, even if it's not yours, and when the bug bounties come, you know, when the bounty hunters come banging on the door, or God forbid the criminals, they're not going to go, I got you. Oh, wait, sorry, that was pre-fork. Never mind. My bad. Now, pen testers will. You can scope the hell out of that in a pen test, right? If you find anything that's pre-fork, that is out of scope. Somewhere, somehow, in GrrCon today, there's a pen tester. Drink 3 will tell you that horror story. But my point remains that when you fork or merge code, you're still ultimately responsible for that code, which can be very, very difficult because even the best-intentioned dev shops focus most of their controls on the code they wrote, even though it's predicated on all this other code. So defenses. 1, check the original source code. 2, crazy idea, make sure you're not in debug mode, especially in published public applications. That would be a great thing to add to a CI/CD pipeline when you're going through all your checks. Have the Jenkins job turn up debug mode before you publish it up to the Apple Store where we can all download it. And then protect those logs, right? When it comes to logs, assume, please, that at some point, at some time, for some reason, there's someone who does something, and you want to smack them on the head, and they write a bunch of data that they shouldn't. Passwords, private keys, usernames, social security, I don't know. Bad stuff is going to get written to your logs. So please, guys, protect those logs, right? Protect those logs as if it has sensitive data, because God knows it's going to get that sensitive data. All right, a couple more. Yeah, a couple more. Unkept passwords. This was kind of fun. Tavis Ormandy is fantastic. You should follow everything he does because he always cracks me up. Microsoft, Windows 10, right? Microsoft is agile now. Whoever thought? And with Windows 10, new features come in and they go out. Things pop up and they pop out. And up pops earlier this year a password manager, which is great. Who likes remembering a million passwords or writing them in a book or putting them in a text file? No one does. So we all should have password managers. LastPass, KeyPass, whatever it is. Awesome, awesome stuff. So pops up in Windows 10. Everyone's like, yay! Actually, I don't think anyone really noticed. No one notices. We'll go with that route. But Tavis did. Tavis went, oh, wow, this is cool, and started playing around with it. The main application, the Apple's Password Keeper, the main application, absolutely fine. Great app. Life is good. Kudos to those guys. They included a password or a browser plugin. The browser plugin had a door to that main application. Of course, you're in a browser, you want to put in passwords. Makes sense. The browser plugin was full of holes. The browser plugin ran in the context where it could get all the passwords because, of course, Password Keeper. The browser plugin had the ability to do code execution within it and take over it. So what that meant is if Tavis could get you to browse to his website and you had Password Keeper and you were using Edge, why are you using Edge? Chrome's a thing. If you were using Edge or a Microsoft browser and you browsed to Tavis's website, he could see that plugin, inject it, grab out all your passwords out of your password safe, save it into a log file, which I'm sure he's encrypted. Sure. And that was pretty cool. So he found that, he reported it. It was another bug bounty that ended up eventually getting paid out. One of the interesting things about this thing, though, is remember early on, some of the things that always happens is companies are afraid of hackers, hackers are afraid of companies. This was one of the cases where things went a little bit off the rails. For whatever reason, the way it was reported and the time it was reported had violated that bug bounty contract. If you guys are going to do bug bounties, please read the contracts very carefully. Please follow them. I'd urge you to abide by those rules. They're usually some pretty simple rules. But Tavis is Tavis, and Tavis is great. And Tavis talked to Ars Technica, and Ars Technica published an article before Microsoft could remediate. And it ended up being a lawsuit. They actually sued the reporter, and they sued Tavis out of it. I don't know the current state of the lawsuit. I couldn't find it, so I'm assuming it's in legal whatever at this point. If anyone knows. Reporter's off the hook? Yeah, good. He's free and clear. Good. Tavis, not so much. Still, good to know. All right. But this brings up a couple good points. One is, please be careful when you're doing this about how it's disclosed and you're following the process. Two is, of course, whenever you're releasing features in an agile way, such as Microsoft just bundling Password Keeper, you're increasing your footprint. And the agile world is fantastic for development, but that also keeps all of us security people up at night because that means every single day there's a new thing that can suddenly be on 1,000,001 desktops and open up everyone to vulnerabilities. And that's a scary thing. That's a scary thing. And there's very few controls around that. So I like the fact that bounty hunters are attacking that space. It's exciting to me. It's exciting to me that they're jumping in and finding these things because better them than that be on the Windows desktop for a year or two and then who knows what bad guys have been doing. But why steal passwords when you can just bypass the authentication altogether? like what happened at GitHub. So GitHub runs Ruby on Rails. This is another bug bounty earlier this year. Ruby on Rails has a session secret. By default, that session secret is a static string that should have as many gasps from the public as the private keys exposed. Because that means if you know that static string, you can do all sorts of bad things. You can sign cookies. You can impersonate users. You can even use it in the case of GitHub's management console to do remote code execution. Some really bad stuff came out of that. When this was found and it made the news, it reminded me of something. Did anyone catch How to Implement Crypto Poorly, Shaun Cassidy, a couple years ago? It's that link. You guys should see it. It was at GrrCon 2 years ago, and he actually walked through several applications that had this exact same problem. What he was looking at is how to implement crypto poorly, but specifically for like OAuth framework, shared secrets, that type of authentication like the GitHub was talking about. And he does a lot of these application pen testing, a lot of this application analysis, and he looked at something like 100 different apps and was finding all the common bad ways people do them. And of course, static shared secret is one of them. So, talk worth seeing. The key defenses here are, hey, don't use static secrets. Right? Change these things up. Use the randomized features and what have you. Don't roll your own auth. Back to what Shaun Cassidy was talking about at GrrCon. OAuth is hard and it sucks and there's a lot of code and you're like, man, I just want to like wire up a user in and whatnot. But trying to roll your own, even though it seems simpler, is a real quick way to open yourself up to a whole bunch of vulnerabilities. So either don't roll your own or have a really well-funded bug bounty program. That's good. Another thing is, very similar to the concept about forking, mind the code you wrote in on. This was not necessarily a GitHub bug. This was actually a bug inherent in Rails. This is how Ruby on Rails is set up. It's how it works. They built the enterprise console on it. They inherited that vulnerability. Much goes into building apps these days, right? And no one builds full stack. No one even builds partial stack. Usually we're building today the integration glue that brings all these apps together. That's where our secret sauce. Why that's important is we're still not off the hook for all the rest of the code we run in on. The frameworks, the web server, the servlets, other libraries we pull into. There's a particular type of analysis called composition analysis that's well worth talking to your developers about. What composition analysis will do is, just like static analysis will look at your code and say, ah, look, there's a vuln. What composition analysis will do is it will look at the code within your code, the libraries you run on, the frameworks you run on, those sort of things, and look for common vulnerabilities in those and report them back to you. Very cool. You can run it off your Git. It takes seconds to do because it's looking at a backend library. Think of like a Nessus for your code, right? Software composition analysis. All right. So with that, let's talk a little bit about a framework for preventing some of these things we heard about in this talk, and then give you a couple of things, and we'll probably finish a few minutes early. So framework. One, protect your authentication. Protect your auth. Usernames and passwords, obviously, we need to protect those. Also make sure that, in addition, do proper hashing, that you're not writing them out to logs, that you're not relying on static secrets, that there's not easy ways to bypass these things. Protect your authentication. Great thing to pen test on as well. Stop injection. Stop injection attacks, your cross-site scripting, any way you can embed code in. The number one way that's being done today is not the old school, here's an input form, I've typed in my stuff, click go. The number one way it's being done today is with the APIs, because that takes a higher level of knowledge to go ahead and test and implement, and because developers are not yet thinking about it. So stop the injection. Any inputs, sanitize the hell out of them. Watch your file uploads, obviously. Watch your file uploads every single time so people aren't uploading shells on you. Clean your code. Clean your code. That means static analysis, if you can, scanning it for vulnerabilities. Dynamic analysis, if you can, watching it in the real world and seeing what people are doing to it. That means composition analysis. And it's not only the code you wrote, but the code you begged, you borrowed, you stealed, the code you copied off of Stack Overflow. All that code, now it's in your code base, it's in your stream, it's your world. And then secure the logs like we were talking about, secure them like they have sensitive data. And now we got all that going. Make sure that someone doesn't go ahead and take over your domain and violate it all because they put up a nice, pretty dialog box and grab your username and password and probably write it to a clear text log file. So pretty simple framework, right? A lot of the stuff we're talking about really boils down to some of the fundamentals of software development security. Why we're not finding these things without bug bounties, I believe, is because we time box pen testers so tight, like I already talked about. So I think you need a pen test to be time boxed, to be tight, to find the things that matter, and then a bug bounty after that to be open, to allow for creative solutions, to allow for people to have plenty of time to bang on it, to get people involved and look at it new and different ways, to attack it in ways that pen testers won't usually think about, vis-a-vis the 5 Google Calendar invites, and really build on that program that way. So there's a framework. Another framework course is OWASP Top 10. Can't beat that. But everyone's like, yeah, OWASP Top 10. Fine, we'll do that. I think what's interesting is frameworks like that, OWASP Top 10, or any of these, get used so much that you start to get to a point where developers kind of glaze over. Yes, OWASP Top 10. Yes, I will follow the CIS. Okay, got it. And that's the other thing is, fundamentally, whether it's OWASP Top 10 or the framework I mentioned earlier, we have to understand and recognize and defend against defend our applications against the very fact that no one ever listens. No one pays attention when we say these things. So we got to have some understanding that they're not going to pay attention. They're going to do their own thing anyways, right? So how can we encourage folks to come in and help us out? All right. Wrapping up the Bounty Hunter section, 3 takeaways. Hey, anyone who's writing code today, we live with a price in our head. We live on our price in our head either from the criminals, because that's where the money's at, right? Why did they break our apps? Well, because you can monetize the hell out of it today if you can get the right data, or you can get the right CPU access. And alternatively, you live with the price in your head if you're doing a bug bounty, which I'd rather have that person, a little bit less money, and they tell you about it. Life is good. Some of the best things to do for developers, if you are developing your own applications, is to implement a secure SDLC, which can put in place the right things as the apps are being spun up and spun down. Simple things like, give me a domain, and when I'm done with that domain, make that domain go away so no one can hijack it. If you're a company, consider doing a bug bounty. I loved Uber's quote, though. Uber got so beat up, they actually issued a statement, don't extort us. I'm like, that's great. Thank you for joining our bug bounty. Please, no more. I can't take it. There is a lot of guidance and resources out there from major companies that do bug bounty as a service versus many folks who built programs and frameworks for spinning up your own bug bounty. I really think it's a great idea. After, of course, a pen test, there should be an SDLC. Should be a pen test, but then opening it up, I think, is a fantastic idea to find some low-hanging fruit and some really creative things that would otherwise be missed. And, of course, if you want to do bounties, there's plenty of ways to get involved. BugCrowd and HackerOne are 2 of the primary ones. They talk to all of us, and they talk to the companies, and they run the bug bounty program, and life is good. And you get alerts, too, and notifications as well when new apps come available, new ways to hack. So a lot of times when folks are coming to me and say, hey, where do I start? What do I do? I want to get into this. I want to play. I'm usually pointing them to this. Because if you think back to one of the first stories I told you, all they had to do was run the right tool at the right domain and pocket $4,000. What a great sense that is. Man, I found something. Yes, money. I love that idea. And though we may look, the graybeards, down on, oh, they're just script kids running scripts. No, I bring all the script kids in, have them go play, let's give them money. It's fantastic. Let's do it. So, great way to start. And that's just level 1. As people get more and more advanced, you can get more and more money and greater challenges. Until after Spectre was on these boards, right? You can now win Spectre-like vulnerabilities, I think are like $500,000 or $100,000 to $500,000. Major, major payouts as you get to be really, really good. So all the way from Script Kiddie to Uber Elite and everything in between. So that's my take on bug bounties. That's my take on bounty hunters. I think it's fun. I think it's cool. I encourage you to go do it if you want to do it. If you write software, I encourage you to go build one. And if you're a pen tester, I encourage you to come out with me for some drinks. So with that, thank you so much.